In this video, we'll talk about the characteristics of attribute labels and variables, and then present the live editing tool. Then, we'll continue with the use of tables, and finally, we'll talk about image scaling and its variations. We'll continue developing our app. Let's remember how the detail screen of a speaker looked like in the app that we presented at the beginning of the course. It corresponds to the image that we see to the left of the screen. In our app, the same screen is seen as it's shown to the right. Note that the screen clearly doesn't have the same design, although they are similar. Then we're going to modify it to get closer to the final design. In this part, we're going to focus on the labels. In our app, attribute tags are displayed above the content. For example, ID or name. For each attribute, we can configure how the labels will look. The options are Platform Default. For Android, it's the top value above the content, and for iOS, it's on the left. None. The tag is not displayed. Left, to the left of the content. Top, on top of the content. Right, to the right of the content. Bottom, below the content. And finally, Float. The label is shown in the position of the attribute or variable content. When the user starts to write, the label moves upwards as if it floated. This only works in editable fields and in numeric or character type fields. In the rest of the types, the value top is adopted. In Android, the value of the label and also the value of invite message must be the same. Otherwise, the value of invite message will be shown. Let's take a look at all of this in GeneXus to try the various ways to show labels. We'll open the object we're looking at, work with device's speaker, and we'll click on the General section. We check the value of label position. For example, in Speaker ID, its value is Platform Default, and the same in Speaker Full Name. Let's see how the screen is shown now in the emulator. The label is shown above the content, which is Android's default value. So we change the value for Speaker Full Name, and we'll use, for example, Right. Let's run the application by selecting Run. One thing you may have already noticed is the time it takes to specify and compile everything and then see the changes in the emulator. We've already installed the application, so let's see how it looks. We'll open Speakers and select a speaker. There we see that it now shows the label to the right of the content as we had indicated. Let's go back to GeneXus. We'll now use a very interesting feature called live editing. This tool will allow us to make changes in themes, languages, layouts, and user events of our panels for smart devices, and then instantly see those changes in the app on the device, without having to compile anything, and without even having to save those changes. We're going to prototype in live editing mode, so we simply change Release to Live Editing and run the application once again. In this case, as it is the first time, it'll be necessary to compile the application again, but the next time we make changes, this will no longer be necessary. The changes will be automatically reflected in the emulator and in the GeneXus IDE. We already have the application ready again in the emulator, only that now we enable live editing. In the IDE, the live editing tab has been enabled. It contains information about the devices connected to live editing. For each one of them, we can see their device name and the theme being used in the app, as well as the language and operating system. We can also see that a new window was opened. It's called Live Inspector. This is one of the main advantages of live editing, and although there is a constraint and we can't see when a menu for smart devices object is running, the rest of the panels can be seen, regardless if they've been developed with Work With for smart devices or Panel for smart devices. Here we can see the list of speakers. Everything we see in the emulator or in the device will be reflected in the IDE within the Live Inspector screen. We select a speaker. If we select a control in Live Inspector, we can see its properties. Properties like speaker full name. And we can change the value of label position to left. And there we can see how it looks. It wasn't necessary to save or compile or run the application again. If now we set the bottom value again, we see it immediately, but we'll leave the value to none. Now we select the Speaker ID attribute. We'll hide this label too. Actually, we'll leave the attribute hidden. We set the visible property to false, and then set the invisible mode property to collapse space, so that when the control is hidden, it doesn't take screen space. Now we change the class of the speaker full name attribute. We'll use the class attribute session title. Note that the change is already included in the IDE. In addition to being able to change the properties of the attributes, in the Class tab, we can edit the theme. We go to Colors and Fonts, and use a brighter color. To do so, in the palette we select the base color, and we can already see the change. Now let's undo this change, because it was just an example to show how to use it. Now we'll assign the class attribute speaker name. Which is the class indicated by the designer. And now let's go directly to the object. Here we can also make changes and see them reflected instantly. In fact, note that it already has the values that we've just entered in Live Inspector. Another thing we can do is, for example, move a control. So let's place the speaker image attribute on top of speaker full name and leave it without a label. We remove the label from company name and assign it the class attribute speaker BioT. And now we do the same with country name, remove the label, and assign the same class. We move the attribute speaker CV mini to the top, below speaker full name. We also remove the label and assign the same class. We select the attributes speaker address, speaker email, and speaker phone. By holding down Control, we can select several controls. We assign it label position top. Let's see how it looks in the emulator. Okay, we haven't assigned the class, so we assign the same class we used before. Let's see how it looks again. Now we'll add a title. So we open the toolbox and add a control of text block type on top of speaker address. In caption, we enter contact. And for the class, text block title widget M. So let's check it out. And it looks great. Now we're going to save the changes because we're satisfied with the design. But now let's look at some other features of the Live Inspector screen. For example, if we click and move the mouse, we can rotate the image in any direction, and note that some layers are seen when we do this. These layers allow us to select them in a much simpler way, since in general they're superimposed when there are sections or tables. With this control, we can increase or decrease the space between the layers. With Reset, we return to the default display. With this control, we can increase or decrease the zoom on what we're seeing, and if we select Pan, instead of Rotate, we can move the content with the mouse without rotating it. Well, that was it. Let's go back now to the presentation so we review other topics related to live editing. Some restrictions of live editing are as follows. It doesn't work in objects of Menu for Smart Devices type. Modifications on server-side events, such as start, refresh, and load, have no effect, so it's necessary to recompile the application. Live editing only works when we have a compiled application. We can't use it when we prototype with KVN. It also doesn't work with Windows 7. So how does this feature work? When we use live editing, the server will be listening to the changes we make and will replicate these changes on the metadata that the mobile device accesses, in our case, the emulator, and that is used to draw the screen on the device and define its behavior. So let's continue with the design, now focusing our attention on the tables. In this section, we will use Work with Devices Restaurant, and if you haven't applied the pattern to this transaction yet, you can do so now. We've also added an option to the menu to access it, as we did with speakers and countries. Working with tables will be essential in smart device applications. Every layout, even when it's empty, will have a root table called Main Table. In turn, every grid will define a table to contain the controls of each line to be loaded. In this case, the table has 2 columns and 1 row. Look at the 2 properties, column style and row style, which will allow us to define the size of each column and row of the table. Let's look at the columns. Their sizes can be specified in 2 units, percentages or dips, device-independent pixels. The device-independent pixel unit corresponds to the abstraction of 1 pixel, which later an application converts to physical pixels in order to scale to different screen sizes. The dip value has a different number of pixels for each platform. Percentages are relative to the value resulting from subtracting the fixed values from the total width in dips. So, if the total width is 384 dips, and there's a column of 44 dips, the value of 100% for the next one means that that second column will occupy the remaining 100%. So, that is to say, 384 minus 44 equals 340 dips. If we had 3 columns, the first with 30%, the second with a fixed value of 10 dips, and the third with 70%, the values that the first and third columns will assume are obtained by applying those percentages to the value resulting from subtracting the sum of the fixed values, here only one, 10 dips, from the width of the table. The second column with 10 dips can be used as a blank space between the first and the third column. For this reason, the space available for the first and third columns is 384 minus 10, which equals 374 dips. Therefore, the first column will have 30% of 374, which is 112 dips, and the third column the remaining 70%, which is 262 dips. Let's take a look at all of this in GeneXus. Now we'll open the object Work with Devices Restaurant, and let's go to the list. Here we can see the main table we just talked about. And within the grid, we can see the table with the name Table 1 that currently has two columns, one of 44 dips and another of 100%, as we saw in the presentation. So then, let's insert an additional column by right-clicking on the grid table and adding it from where we're positioned, Restaurant Image. We enter a value for column style, as we've seen before. We'll do 30% for the first column, 10 dips for the second, and 70% for the third column. Now let's run the application to see the result. We're using live editing, so we can see it directly. And here we see that it's changed. Now we have a space between the name and the image. We'll add the attribute restaurant address to the grid. And we'll remove its label by setting its label position to none. So now in Live Inspector, we can't see the change currently. This is because we're changing a server-side event, a load. So, in this case, it is necessary to recompile the application. So we press Run again. While generating and compiling the application, we'll review the rows of the table. We see that the PD unit platform default has been added. This value varies from platform to platform, and for the same platform, it also depends on the content of the cell. For example, if the field has a label or not, and if it does, if the label will be displayed at the top or to the left, or if we're in a layout, in edit mode, or in view mode. The PD value corresponds to using the best value depending on the platform and context. So for example, for Android with label position equals top, it corresponds to 64 dips, and in iOS, it's 53 dips. Let's see how it all looks. Okay, we can see the address. So let's change its class. We'll create a class attribute restaurant address, and we'll configure it. We remove autolink. We don't want it to have the icon to go to the address. And we set font weight bold, and that's it. We already have the design, so we save and continue with the presentation. We're going to see some properties of the images, more specifically, the different values that we have for image scaling. They're as follows. No scale. The original size of the image will be kept regardless of the size of the area where the control is located. Tile. In this case, the images are not scaled and will be repeated to fill the control area. Fill. The image width and height will be scaled to occupy the area where the control is located. Fill keeping aspect ratio. This is similar to fill, but the image will always keep the same width and height proportions. In this way, the image is never skewed. For example, if the image size is 100 by 200 pixels and the control area size is 50 by 50, the image will be converted to 50 by 100 pixels. Fit. The image width and height will scale so that it can be fully displayed, keeping its proportions and aspect ratio. So for example, if the image size is 100 by 200 pixels and the control area size is 50 by 50, the image will be converted to 25 by 50. This is the default value. Let's return to GeneXus and see this using live editing. So this is what the list of restaurants looks like now. Note that the images are not looking very good. and this is due to image scaling. So we'll try to fix this panel. The first thing we'll do is we'll make this image occupy 2 rows. To do so, we'll use the row span property of the control. We're going to indicate that it takes 2 rows, and we'll delete the column that was added automatically. Now note that we had a column of 30%, another of 10 dips, and 70% the remaining one. Let's see how it looks. Note that the images are still a little bit skewed, and this is due to the scale type property. The class of restaurant image is image, and we'll see that in scale type there aren't any values. Now let's change these values so we can see how they're changed at runtime. No scale remains the same. In tile, we're not going to see this effect. Well, in this case, if the last image, this image is smaller than the size of the control area, therefore the image is repeated to fill the available space. Let's try fill. Note that in this case, the image fills all the available space, but it's skewed. Now let's try fill keeping aspect ratio. Note that now the image fills all the available space, but the image aspect is maintained. And finally fit, which is the last value we had left. Fills the area, but doesn't take all the available space because it maintains the proportion when filling, but doesn't do so by completing all the available space. So, we leave the option that looked best, which was fill keeping aspect ratio, and it looks perfect. Let's review everything we've seen in this video. We saw the various options for label position: platform default, none, right, left, top, bottom, and float. The last one is only used in edit mode. We've learned how to use live editing, using the Live Inspector tool, and we talked about the restrictions for its use and the architecture of this tool. Regarding tables, we saw how to specify the styles of the columns and rows. We talked about measurement units, dip, percentages, and the value PD, platform default, for rows. And finally, we talked about image scaling and its different values: no scale, tile, fill keeping aspect ratio, and fit.